Hi everyone, Tom Loria here. Welcome back to the shop. Before I get started with this video, I'd like to take a moment to say thank you to all who have subscribed and to those who have left comments. I've heard from people all over the world, in Italy, the Netherlands, Belarus, Australia, just to name a few. I really love hearing what you have to say. I enjoy reading them, so keep them coming. I would also like to give a shout out to another YouTube channel. The ClickSpring channel has some fabulous content on it, and its host, Chris, is really an amazing artist. Watching him has inspired me to try and take my metalworking to the next level. I'll include a link to one of his projects in the description below. I strongly urge you to check this guy out. You'll be glad you did. So on to today's subject. My latest project is a 1/24th scale model of a Wianno Senior. This is a one design built by the Crosby Boatyard in Osterville, Massachusetts. The first boats, 14 of them, were built in 1904 at the request of the Wianno Yacht Club, also in Osterville. They wanted a boat that would level the playing field for all the competitors in their weekly races. They asked the Crosbys to design the boat specifically for the wind and wet water conditions on Nantucket Sound. After the first 14 boats were delivered, orders for more boats followed. Since then, more than 200 have been built. The seniors built today have fiberglass hulls, but they meet all the class specifications, so that wooden boats and glass boats can and often do compete against one another. Number 7 here is one of the original 14 boats ordered in 1904. The Wianno Seniors are popular along the south shore of Cape Cod, in part because of their ability to handle the 25-knot winds that frequently come up in the afternoons along the Sound. The boats became so popular, in fact, that Joe Kennedy bought one for his son John. The young Kennedy loved that boat so much that he kept it all his life. In later years, Senator Ted Kennedy, who also loved sailing the Victoria as much as his older brother, said he firmly believed that the lessons JFK learned while sailing that boat were directly responsible for his survival during World War II. Now, this model presented me with many challenges, but I found the metalwork particularly tough. On the aft side of the mast, there is a dovetail slide made from wood that the gaff, mainsail, and boom all use to raise sail. I know form is supposed to follow function, and I guess it does in this case too. But it just seems like they took the long way around and these pieces were overly complicated. The gaff traveler and boom gooseneck that you see in this photo took about a day and a half to make. But we're here to talk about turnbuckles. This model needs 3, all 12 inches long from end to end, and about an inch in diameter. To make the barrel, I used 46 thousandths brass tubing with an inside diameter of 32 thousandths. The inner sleeve is 32 thousandths tubing with an inside diameter of 20 thousandths, and the eye bolts are 15 thousandths musical wire. That covers the material. What about tools? In this photo you can see the tools are pretty basic. Files, jeweler's saws, a pliers, sandpaper, and a sewing needle, the diameter of which matches the inside diameter of the barrel. That's important. While working on the barrel, it would be pretty easy to distort the fragile tubing. Inserting the needle into the tube gives it the necessary rigidity for the somewhat rough handling it will go through. I threaded the music wire with a jeweler's screw plate, part of a kit I acquired at an auction of ship model builders' tools. There are left and right threads for the plates and the taps. However, there was not a matching pair of taps for the diameter needed for my eye bolts. So for this project, the threads are strictly ornamental. I used layout fluid on the barrel and marked out the length and the 2 stop cuts for the recess. This is what I ended up with. The mark closest to the vise is the overall length of 3/8 of an inch. and the remaining 2 marks are the stop cuts, marking the ends of the recess. I inserted the needle into the tubing and clamped it into a machinist vise. And to make the recess, I started by cutting inside the marks with a jeweler's saw. It only took a few strokes for the saw to break through to the needle inside, and it was easy to tell when I reached it because the saw would start to grab and hang up. Once the 2 cuts were made, the piece was flipped over and the process repeated. Filing was done in stages. I removed the bulk of the material with a 0-cut file. Next, I used a number 2 file to clean that up, and then to clean that up, I used a number 4 file. Like most everything else with this project, I'm doing things twice. So once I was satisfied with that side, I flipped it over, did the other side, and when I was satisfied with the way it looked, I took the needle out, and then I prepared a piece of 600 grit paper about 2 or 3 inches long by 1/4 of an inch wide. I wanted the paper to be wide enough to fit into the recesses from end to end. This should minimize any chance of sanding a distortion into the recess. I folded it in half so that the abrasive was on both sides. Now I used this to clean up both sides of the recess at the same time and remove any burrs that might have been left from the filing. And speaking of burrs, in this second view, if you look carefully, you'll be able to see at the bottom of the recess a small shiny burr. And as I sand, you'll also be able to see it come right off. That's why it's so important to do this step. Sanding the inside of the barrel is an important step and really should not be overlooked. With all the filing done, it was time to taper the ends of the barrel and part it from the excess stock. So I mounted it in the lathe, and I really just used a file here to perform both operations. I tapered one end, then tapered the other, and as I did, it eventually filed right through and parted the turnbuckle barrel right off. I gave the barrel a quick buff with a fine abrasive wheel. Using the sewing needle as a mandrel has its advantages. It provides the rigidity needed to keep the barrel from distorting. It also provides a good handhold while working on the piece away from the vise. And the eye of the needle prevents the barrel from flying off the end, never to be seen again. After a few passes with the wheel, I was satisfied and moved on to making the other components. Eye bolts came next. And to make the eye bolts, I started with a short piece of 15 thousandths music wire mounted in a pin vise on the lathe. The ends are tapered down with a file in preparation for being threaded. Since the threads are strictly ornamental, I didn't have to worry about making left and right hand threads. I made both of them right-handed. Perhaps the next project will have working turnbuckles and opposing threads. The screw plate was fed onto the wire and the threads cut for a distance of about 3/16 of an inch. The plate was backed out, the piece was swapped end for end in the pin vise, and the whole process was repeated. I now had a piece of musical wire that was threaded at both ends, ready to be cut in half and made into eye bolts. If you saw my video on making shackles and thimbles, then you saw how I made eyes using a pair of specially modified pliers to do the job. For this project, I was able to use a pair of commercially available ring pliers. They were a bit on the expensive side, but they work so well and are so well made that they're definitely worth the price. The music wire is tough stuff and can be difficult to work with. But for this application, its toughness was definitely an asset. One word of caution though. Use only hardened steel cutters for trimming and cutting. something like a good pair of end nippers or a good pair of diagonal cutters. Regular hobby cutters like Xuron or even Lindstrom cutters will be ruined on the first use. Off camera, I prepared two small pieces of 32nd inch brass tubing to act as sleeves between the barrel and the eye bolts. These needed to be only about 1/16 of an inch long, just long enough not to extend into the open recess of the barrel. They're necessary to take up the space between the eye bolts at 15 thousandths of an inch and the inside diameter of the barrel at 32nd of an inch. With these parts done, I had all 5 pieces ready for assembly. All the parts were scuffed with an abrasive wheel and washed with denatured alcohol in preparation for soldering. The only thing left to do was to put it together and apply a little heat. With the turnbuckle completed, it was time for one last bath with a bit of denatured alcohol, and then another turn on the buffing wheel, and it's ready to be installed on the model. I've made turnbuckles in the past, but they were simply nothing more than a length of tubing with an eye bolt at each end, sufficient for getting the point across, but hardly realistic or aesthetically satisfying. Working out this whole process and figuring out which materials are best suited to the task allowed me to advance my techniques for use on future projects. I will no doubt try making working turnbuckles, probably for my next project that needs them, but that'll be a technical leap for the near future. When I do make that leap, I will post a video. But if you have any questions in the meantime about this video or anything ship model related, leave me a comment below. As I said at the beginning of the video, I love hearing what you have to say. Or you can jump over to my website and go to the contact page and send me an email from there. So, until next time, thanks for watching, take care. Now, get back in the shop.